Welcome to section 3.1 and 3.3 combined. So we're looking at quadratic equations and inequalities. And first, let's take a quick look at complex numbers. We don't focus too much on this, so we're just doing a mini sort of review for it. So complex numbers, it basically comes from when we have the square root of a negative number. And we call that number I for imaginary number. And that again is equal to the square root of negative 1. And then if we square I, it'll get rid of that little square root and we're left with the negative 1. So I squared equals negative 1. Now complex numbers are where we have a plus bi, where a and b are real numbers. And then we have that little I part. So let's take a look at example 1 and write it as a complex number in a plus bi form. So notice we have that square root and the 9, and there's a negative. So I'm going to go ahead and split that up into negative 1 times the square root of negative 9. And we know that the square root of negative 1 is equal to I. So that's going to be I times, and then the square root of 9 is 3. But usually we write this where there's the 3 is first and the I is last. So in correct complex number form, it's going to be 0 plus 3i. Why would I write 0? Because we don't have a real number part, but we still need to write it in the proper form, so my a value would be considered 0. Now let's take a look at b. And let's see, we have 7 minus, again we still have that negative under the radical, so we'll go ahead and split that into the square root of negative 1 times the square root of negative 12. And then the I, again, comes from the square root of negative 1. And then we can simplify the square root of 12 into the square root of 4 times the square root of 3. And then the square root of 4 again is 2, so I'll rewrite this as 2 root 3i. Now be careful, notice I did this little tail on my radical. It's good to do that so you know that the I is not inside the radical. And again, that is in complex number form with the real number part of 7, and then the imaginary number part, 2 root 3i. Now for C, what do we have going on here? We have two binomials being multiplied together. And they're actually conjugates. One's a positive and one's a negative. So I'll go ahead and use the difference of squares to FOIL this out. You could do the long-term FOIL, or you can notice that they're conjugates. So we'll go ahead and square the first, minus, and square the last term. And that'll be 25 minus I squared. And what is I squared? Again, I squared is negative 1. So 25 minus negative 1, which will be 25 plus 1, which is 26. But again, we want to do it in complex number form, so how many I values do we have? None. So we'll just go ahead and write 0i. All right, so now let's take a look at quadratic equations and inequalities. Again, we have a quadratic equation. We have an a value and then an x squared. That's the thing that makes it quadratic, is that x squared. And then a bx plus c equals 0, where a, b, and c are real numbers. Now one property we have for solving these is the square root property. Basically we have our x value squared equal to a number, and then we can take the square root of both sides and have plus or minus k. Again, you need to be careful. We need to remember to have that plus or minus value because that gives me two numbers. How does this make sense? Well, again, if you're thinking of square rooting something, you're saying what times itself would give me that number. Again, if we're thinking of square root of 4. Well, we know that 2 times 2 would give me 4, but what other number could also give me a positive 4? Yeah, a negative 2 could also give me a positive 4. So because of that, we know we have the positive option and the negative. So we need to include two possible options for our answer. So an important thing to know when you're figuring out how to solve a quadratic is which method to use. And each method has a different reason why you might use it. Square root property, we use it because we have just our variable squared, and the variable doesn't appear anywhere outside of the squaring. So looking at our first equation, notice our variable only appears once and it's squared. This is perfect time to use the square root property. So we'll just get the numbers to the other side. Oop, let's plus that. And then we'll go ahead and divide by 2. And then square root both sides. Again, super important, you need to do that plus or minus because we need to have two answers. And then, let's see, x, the square will cancel out with that. And what are we left with? Well, we can simplify the square root of 24 into 2 root 6. And then we're done. So again, best way to know to square, or to do the square root property, is if you have your x just by itself in one place, being squared. So this next one, again, that falls into the perfect category for square root property because we just have our x squared, no other x terms hanging around. So we'll go ahead and set up for that, get all the numbers on one side, and then take the square root of both sides. And remember, we need to do that plus or minus symbol, very important. That cancels with the square, and we have x equals plus or minus the square root of negative 16. Oh, we have a negative under the radical. So if we're not solving over complex numbers, we would say there is no real solution. But if we were solving over complex numbers, we would switch this into the complex number form and write it out as 0 plus or minus 4i. All right, let's take a look at the next one. Now this one looks a little different. It's not just my x value squared. There's an x minus 2. But in general, it is being squared. So because of that, we're going to go ahead and use the square root property. We'll add 7 to both sides. And then I have my x value inside something being squared. Perfect setup for the square root property. So I'll go ahead, square root both sides. That square root, again, will help me cancel that 2 out, which is why we do it. We have x minus 2 is equal to plus or minus the square root of 7. Lastly, we just got to get that 2 to the other side. So we'll add 2 to both sides. I always add it in front of the plus or minus. It makes it a little easier to understand. And we have 2 plus or minus the square root of 7. Which we can't actually simplify because the square root of 7 can't be broken down further, so we'll just leave it as that. Next, we have the zero factor property. So before, again, we only had the x squared term in our equations. When we don't have that, or we have something different, we're going to have to use some different properties. So for the zero factor property, if a times b exists and it's equal to 0, well, we know that either a must be equal to 0 or b must be equal to 0, because that's the only way to get 0 from multiplication is if one of them is 0. So notice in this equation, how many x values do we have? We have x squared and x. So this wouldn't be good for the square root property, but let's go ahead and try factor it. Well, we can pull out an x from both, and then we're left with x minus 15 equals 0. So by the zero factor property, we know that either x equals 0 or x minus 15 equals 0. So the first one is already solved. The next one, we'll go ahead and add 15 to both sides, and we get that x equals 15. Awesome, not too bad. So let's go ahead and work on b. So at the moment, you might be tempted to try factor this, but careful, that negative 4 is still on one side, so we need to move it to the other side. Again, we have to set it to 0 to do the zero factor property. So we'll add 4 to both sides, setting it up to use the property correctly. And now let's go ahead and try factor. If you need any help factoring, again, this would be considered a skill from before classes, but if you need any help, let me know and I'll send you just some worksheets to practice. So again, we know that x minus 2 should equal 0. I just do it twice because technically that's the way to do it. Some courses it doesn't matter. Differential equations it would matter. So I just get into the habit of doing it twice. Now let's take a look at C. Again, it's not set to 0 yet, so we have to do that first. We got to get that 20 to the other side to set it to 0. So I'll go ahead and minus 20 from both sides. Now, can we factor this? Well, 2 can only be broken up into 2x times x, and then let's see, factors of 20. If I do 4 and 5, and then I take the factors of 2, 2 and 1, can I multiply them around to get a negative 3? Well, 2 times 4 is 8, and 5 times 1 is 5. I can subtract those to get a negative 3. Yeah, awesome. Again, if you need any extra help on the factoring, let me know and I can give you a worksheet. So that's going to be 2x, and then I believe it's going to be, let's see, we're going to do minus 5. No, that's 5. So 2x plus 5, and then x minus 4. And then again, we'll set these factors equal to 0 to solve. So x is going to equal 4, and x is going to equal negative 5 over 2. Let's take a look at D. It'd be hard to factor this the normal way, because factors of 1 can't really give us 4. So you know what? I can either try the quadratic formula, because this doesn't factor, or I can do completing the square. So again, completing the square, you're going to get your x terms together in parentheses, and then leave your term without x on the outside. And our goal is to find some number we can add to this side of the equation in order to make that factor. Again, my goal is to add a number that'll make it factor. And the sneaky way to do this, which I can show you for the proof, or I can show the proof to you if you're ever interested. We'll take the middle number, divide it by 2, and then square it. So that's going to be 2 squared, which is going to be 4. So 4 is the perfect number that we're going to add to this trinomial to make it factor perfectly. But if I add 4, I have upset the balance on the equation. So 2 options. I can either add a minus 4 to this side, or I can add a positive 4 to the other side. Different ways to do it. I'll go ahead and just, let's see, what should I do? I'll add 4 to the other side. Why not? Again, 2 different ways, both would work. So now we found that perfect number, and why was I doing that? Because I wanted to be able to factor it. And this factors perfectly into the binomials x plus 2 times x plus 2. Isn't that awesome? Again, sort of a sneaky way of being able to factor. Then that's x plus 2 squared minus 1 equal to 4. Does this look like a familiar thing? This is perfectly set up to do the difference of squares. Not the difference of squares, sorry. This is perfectly set up to do the square root property. So we'll go ahead and plus 1 to both sides. And then we get x plus 2 squared equals 5. Let's go ahead and square root both sides. Remember that plus or minus. Then we get x plus 2 equals plus or minus the root 5. Again, remember, that square cancels with the square. And then minusing 2 from both sides, we'll have x equals negative 2 plus or minus the square root of 5. Again, so if you have a hard time factoring, you can always use completing the square. Find that perfect number to add in. When you do that, though, you have to balance your equation. Make sure to add it somewhere. And then continue on and use the square root property. Now, let's take a look at the quadratic formula. So this one works if any, or if all your other methods fail, the quadratic formula is the one that will work. But it's a bit big. And you need to identify your a value, your b value, and your c value, and then plug it into the formula. Opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2 times a. So again, best thing to do first is to identify the a, b, and c. For this first one, a is 1, b is 4, and c is negative 1. So plugging it into my equation, I have the opposite of 4, plus or minus the square root of 4 squared minus 4ac. Let me go ahead and extend that square root. Over 2 times a, and a is 1. Whew, let's go ahead and color code that so you see what's happening here. That's b and b. And then, let's see, we have a, and then c. Okay, and simplifying. X equals negative 4 plus or minus the square root of, adding that all together, that's going to be 20 over 2. And then simplifying that, we get x equals negative 4 plus or minus the square root of 20. We can simplify that to 2 root 5 over 2. And then we can go ahead and factor out a 2 from the top. So that'll be 2 times negative 2 plus or minus root 5 over 2. And then those 2's cancel. And so my answer is x equals negative 2 plus or minus the root of 5. And we're done. So again, feel free to pause the video and try this out by yourself. What are my a, b, and c values? A is negative 1. B is negative 3. Ooh, what is c? Is c 4? Careful, we need to get it into the actual correct form of equal to 0 before we do this. So we have the minus 4 from both sides. And then we can correctly pick off the c value. There we go. Now we can correctly pick off the c value. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. That's going to be positive 3 plus or minus the square root of negative 7 all over negative 2. Ooh, what do you notice? We have a negative inside that radical. We're going to the complex number realm. And again, in my instructions, we are told to solve over the complex realm and write it in a plus bi form. So we're going to go ahead and continue. So that's going to be 3 plus or minus, that's the square root of negative 1 times the square root of 7 over negative 2. That's going to be 3 plus or minus square root of 7i over negative 2. Now careful, this is not considered the correct form yet because they're not fully split. We need to split that negative 2 between them. So that's going to be x equals negative 3 over 2 plus or minus negative root 7 over 2i. That would be one way to do it. A few different ways to do it, but again, that would be one option, which splits into the two answers. X equals negative 3 over 2 plus square root of 7 over 2i. And x equals negative 3 over 2 minus the root 7 over 2i. Again, splitting between the positive and the negative version. All right, let's go ahead and move along. We're going to use this graph to find the following. When f of x equals 0. So again, we're trying to figure out the x values that make my function equal to 0. So finding x that does the following. So when is f of x equal to 0? Well, that's when it crosses the x-axis. So it's at the points negative 4, negative 2. Next, we're asking when is f of x greater than 0? Well, these values here and here. And then we're going to answer in the x values. So that interval is from negative infinity all the way up to, boop, negative 4. But not including, because again, we're not using including. And then it starts again at 2, and then continues on to positive infinity. Next, now we're looking at when is it less than 0. That's these values here. Again, not equal to, just less than. So that's from negative 4 up to 2 and everything in between. Now next, we're moving on to something very similar, but this time, what does it have? It has the equal to symbol. So we want to figure out when this is, or when f of x is greater than or equal to 0. Which again, be the same thing, but this time we're going to include the n values of negative 4. So we'll include it, union 2, including it, and infinity. Again, these are including values, and these ones are not including. So for less than or equal to 0, again, these values, let's do a different color. These values, but this time we're including the n's. So that's going to be negative 4 to 2, and that's it. Now the next question is, what is the vertex? And the vertex for parabolas is the minimum number, or the center bottom point, or sometimes the center top point. That right there is the vertex. What point is that? That is -1, -3. So that'd be my vertex, -1, -3. Now careful, this is not an interval notation, that is point notation. With an x value and a y value. It can sometimes be confused with interval notation, like we had up here, but again, this is interval notation. From -4 to 2, this one is point notation. Simply a single point on our graph. Now, what are the x-intercepts? Well, again, these two are the x-intercepts. It's where my function is equal to 0. So those x-intercepts, if I answer in proper form, are going to be -4, 0, and 2, 0, where we indicate that they're intercepts because the y values are 0. Again, so be careful with interval notation and point notation. So now we're going to go ahead and look at solving quadratic inequalities. First, you're going to solve the corresponding quadratic equation, like we've been practicing before. Then we're going to identify the intervals determined by the solutions, and then test the intervals. And to find the intervals, you need to find your critical values. I call them CV, critical values. So let's go ahead and solve these. Again, notice they're they're inequalities because of those symbols, so we know we can't just solve like normal. We're going to have to find critical values and then do testing. But first, we'll go ahead and solve it like normal. So we'll go ahead, -9 to both sides, set it equal to 0. Main thing, again, remember to set it to 0. Then let's factor this. That's going to factor perfectly into, let's see, x plus 9, and then 2x minus 1. Less than or equal to 0. So now I can use this to find my critical values. My critical values are 2x minus 1 equal to 0, and x plus 9. So x minus 9 and x equals 1/2 are my critical values. Usually they'd be our solutions if we weren't working with an interval. So again, these are my critical values. These are going to break up my solution set. So now we have to go ahead and do some testing. And I'll show you how I set up my testing. Again, we have our critical values, -1/2, or -9 and 1/2. And we want to pick some test points from between the intervals. But what are we testing? We're testing the factors. Because again, we want to find what numbers, when I multiply them together with these factors, are going to be less than or equal to 0. So we're going to test that. What numbers will be less than or equal to 0 when I plug them into here? So you could check a bunch of numbers, or we could just do this simple testing. So again, we're testing our binomials, and we want to see what their end sign is. And then my goal on this, again, is I want to see, is this less than or equal to 0? Because that's what I'm trying to figure out. Okay, so setting up our testing. I want to pick a test point from the interval less than -9. I'll pick -10. Then between -9 and 1/2, I'll pick 0. 0 is always a nice number to pick. And then what's a number greater than 1/2? How about 10? Again, I'm picking the intervals, or I'm picking my test points from those intervals. You can pick whatever test point you want. I just pick those because they're easy numbers to work with. And then let's do the testing. So we're going to go ahead and plug -10 into x plus 9. What would I get? Right now, all I care about is the sign. So that's going to be a negative number. Then if I plug it into 2x minus 1, what sign would that give me? That would give me a negative as well. And again, remember my goal? I'm trying to multiply these two guys together to get something less than or equal to 0. So I'll multiply these two signs together. What would I get? I get a positive. Again, all I'm caring about at the moment is the sign, less than or equal to 0. That's a positive. Is that less than or equal to 0? No, it's not. So this part right here is not going to be part of my solution set. Let's go ahead and move on to 0 and test that. Plugging 0 into these, that's going to be a positive, and that's going to be a negative. So positive times negative, what sign is that going to be? Ooh, that'll be a negative. Is that less than or equal to 0? Yes, it is. So this interval here is going to be part of my solution. And again, remember, we're filling in the equal signs here because it can be equal to those numbers. How do I know that? Based on the inequality sign I was given in the beginning. We had that equal to symbol. Now let's go ahead and test 10. Plugging 10 into here, positive number. Here, positive number again. So positive times positive is again a positive. Is that less than or equal to 0? The answer is no. So this part would not be part of my solution. So these two parts tested negative, so they're not part of my solution. Just the inside part is. Oh, let me rewrite that. So, writing my answer in interval notation, we start with from -9, including -9. And then we go all the way up to a half, and again, including a half. And we're done. So same thing we're going to do for B. We're going to factor it. We'll set it to 0 first, factor it, find the critical values, do the test points, see which intervals work. So in this case, we're actually looking for something greater than 0. Before, we were looking for something less than or equal to 0. So my goal in that way is going to change a little. But let's go ahead and factor. We can take out 3x, so that's going to be left is x plus 4 greater than 0. Let's go ahead and divide by 3. That won't change my sign because it's a positive. So now my critical values are going to be x equals 0 and x plus 4 equals 0, which is x equals -4. These, again, are going to be what splits up my intervals and helps me pick my test points. So -4 and 0. And then let's see again, splitting it up into 3 little intervals. When you have 2 test points, it'll be 3 intervals. So again, first we'll pick our test point. From inside here, I'll pick -10. From in here, how about -2? Why not? And from in here, I'll pick +10. Again, you're just picking a number, random number, whatever you want, as long as it fits in that interval that you picked it from. For example, for the center number, we wouldn't have been able to pick anything smaller than -4 or bigger than 0, which is why I went with -2. And then again, we're going to go ahead and write down our factors from above here. Then we're going to check the sign, and we want it to be greater than 0. Again, we want to be able to multiply these two, whatever numbers we input there, and get something greater than 0. So we'll see what our sign is, and again, my goal is for it to be greater than 0. So if I plug in -10 into here, that'll be a negative. Into here, again, a negative. So when I multiply these two together, it'll be positive. Is that greater than or equal to 0? Yes, it is. Awesome. So again, this part is going to be part of my answer. Do I fill in the bubble? No, because I didn't have the equal to sign under there. All right, let's move on and test the next part. Throwing in that -2, that'll be a negative. Putting it in here, that'll be, a positive. Positive times negative is a negative. Is that greater than or equal to 0? Or sorry, greater than 0? No, it's a negative. So we're not going to bubble in that interval. And lastly, testing 10. Plugging it into there, positive number. Plugging it into here, positive number. I don't care on what number it is. I just care about the sign for these problems, positive or negative. Multiplying those two together again, because we multiply these two together, that'll be a positive. Is that greater than 0? The answer is yes. So because it's greater than 0, it'll be part of my answer solution. So again, those are my answers. Those are the numbers that work. So in interval notation, we start from -infinity, continue to -4, don't include it, union, where we pick up again is at 0, and continue on to positive infinity. Alrighty, and that is it for this section. Again, please email me if you have any questions. If you need any help with factoring, again, let me know, and I can send you a practice sheet for that as well.